Let's do this. And I would like to introduce Dr. Danny Cunningham, who I have founded as a electrochemical engineer, which is incredibly cool. His role is Deputy Director of Technology at ARPA-E, which is a mouthful, but also incredible that he's doing that kind of work and that kind of expertise that we can have at a breakout session. So I'm really excited for that. This will be our final breakout session of the 2023 SOSV Climate Tech Summit, which is, it's been great. Just 20 incredible sessions. I hope people have been enjoying this, learning from people who are offering these resources. People are offering capital, mentorship, talent transition, all sorts of things. I've seen incredible questions from the audience. And so, as is our final one, I'm going for the last time to say in the chat, let us know where you are calling in from, what you're up to, what are you working on, anything else interesting. This is the last one. I'd like to see some interesting, funny engineering stories maybe in your chat. And then the Q&A, of course, is where we put the questions. That is where you put questions. That's where you're going to upvote. That way, Danny can see those, okay? And with that, Danny, the floor is yours. I'm going to hop off, but I will be present. The share screen looks fantastic.
All right, excellent. Well, thank you, Stefan, and everyone at SOV for giving me another chance here to give my presentation. It's good that I'm the bookend, if you like, for the breakout sessions before the very end. So I appreciate that. So as Stefan mentioned, my name is Danny Cunningham. I'm the Deputy Director for Technology at ARPA-E, and I'd like to talk today about the different technologies that we're involved in, how we work at ARPA-E, how we operate, how we take technologies from ideation to SCALEUP. So firstly, I just want to go over our mission. We have 5 main elements of the mission. Our overall goal, though, is to enhance the economic and energy security for the United States through the development of energy technologies which help reduce imports to US, improve energy efficiency, and reduce emissions. And then in the last few years, we've actually added on a couple of extra mission areas. One is to improve radioactive waste management in the US, and the other is to improve energy infrastructure resilience, our grid resilience, as we see as climate changes and also as stress, as more electrification happens within the US. I think to take away, though, is the other goal for us is to ensure that the United States maintains its technological lead in developing and deploying these advanced energy technologies for our mission. So when we think about the progression of energy technologies, we often look at how cost and performance improves as scale increases. And for our primary R&D programs, and indeed ARPA-E is an R&D agency, we often set targets that far surpass the existing technologies. So at ARPA-E, these early stage programs focus on supporting high risk and potentially transformative research. And as such, we expect that many will fail, but for us, it's many shots on goal. We'll get hopefully that goal, which will make the big difference. And as a result, some do overcome these challenges and are able to prove out their value, performance, and implementation for the technology, surpassing the existing incumbent technology and therefore being the go-to technology. So these are some of the problems that we're looking to solve at ARPA-E. I mentioned about grid and resiliency in energy infrastructure, and that's an important factor for us. Making sure that the solutions that we help support are affordable and sustainable, provide affordable and sustainable energy for all, and energy equality is an important factor too. As is developing the US economic development within the US, which means creating new companies and new products in the energy space. And then lastly, but no means least, American leadership in science and technology, as I just mentioned. Like many organizations, we have impact indicators to look to see how well we're progressing, how impactful our federal funding is, and As of the start of ARPA-E in 2009, we provided just under $3.6 billion worth of R&D funding for more than 1,500 projects in the United States. Of those projects, over 212 projects have attracted more than $11.5 billion worth of private follow-on funding. And we've also helped create 149 new companies. In terms of exits, sort of later stage investments, second round investments and M&As, etc., acquisitions and IPOs, we've seen 27 exits for ARPA-E supported projects and companies with about a valuation of about $21.8 billion. There are other indicators we look for, including projects within the additional federal government agencies, which have become more likely now with Bill and IRA and the onset of OSED, the Office of Clean Energy Demonstrations, and expanded LPO. But importantly, we also look at patents as well, because patents we see as a pathway for licensing technologies to third parties. So just some indication of the indicators that we have. So from an operations point of view, I want to start out and show that where we work within the ecosystem. I mentioned that ARPA-E is primarily an R&D organization. So on the left-hand side of this chart, you'll see that we're helping early stage researchers, and 55% of our awardees are universities, sort of do that fundamental research to break over this not valley of death, but mountain of opportunities, we like to say, into the prototype stage. And we've developed in 2019 a new program called SCALEUP, which I'll talk more about in a few minutes, which helps overcome and de-risk those technologies so that other investors, private investors, can actually help go from the prototype to demonstration phase. So this is how we sit, if you like, with ARPA-E within this innovation ecosystem. So what makes an attractive, compelling ARPA-E project? Well, impact is the first one, of course. We look for high impact areas. We look for a credible pathway to market and potentially in the future, large commercial application. They need to be a transformative project, really changing what's possible. As I say, going beyond, as I said before, going beyond that incumbent technology, really disrupting the existing learning curves. And so that development and innovation can happen much faster, leaping beyond today's technologies. We look for a bridge to translate this science into this technology, which everyone can use, that can be competitive in the open market, and that wouldn't be funded anywhere else. So we look for these white spaces which don't fit in either public or private funding, and helps catalyze this new interest in investment. And lastly, I know is the team. We look for best-in-class people in the team. We look for cross-disciplinary skills, not just from one particular sector. So we might mix electrical engineering, mechanical engineering, a fundamental physicist, maybe manufacturing engineering as well. So that the team is really translation orientated, meaning that they have the right skill sets to take them to the next level. So for programs, I can quickly talk about this. We typically have about a 4-year program cycle where a program director at ARPA-E will start a definition of a new program, reach out to a community, have a request for information, maybe have workshops to determine whether this is really a particular area they may be interested in, is going to be worthy of maybe a $30 to $40 million program. We then create a funding opportunity announcement, which is the framework of the program, put that out for competition, a very competitive competition, and select a group of projects within that program, which will be actively managed over the next 3 years, going from starting at the first part from early stage research, and then by the 3rd year looking for what happens in month 37. After 36 months is 3 years, 37 months, what are you going to do after the ARPA-E project? And that's a project handoff time. That's scale up, potentially scale up, or even private investment in terms of seed or Series A typically. This is our program portfolio, a busy slide. I'm not going to talk too much about this. Each icon has a name associated with a program that's either new, active, or alumni, in three main buckets of electricity generation, efficiency, energy efficiency, and transportation. So at the top, you might see some programs such as GOFERS, in the electricity generation delivery, which looks to develop very low-cost undergrounding for power distribution, so that it will be resilient to weather events and other such disruptions. There's also the HESTIA program in efficiency, which is looking at new materials for building, which are carbon neutral or even carbon negative. And then in transportation, to give you an idea, an example is EVs for All, a very new program where we're looking to support research groups who are looking to develop new versions of transportation batteries that for EVs that look to increase their capability for rapid charging and also for low temperature performance. To give an example, to really help accelerate the adoption of EVs and also move away from detractors who might be either against EVs or not be supportive of them. So an underpinning of those are all our open programs and are also our seeded competitions, exploratory topics, which are often a way to help understand whether a particular area can go to a full program. So a number of different activities, program activities in ARPA-E. So now I'm going to talk about, as I come into the scale-up portion of the presentation. Scale-up, as I mentioned, we started in 2019, and while our primary R&D programs that you can see on the left-hand side cultivate potentially disruptive technologies and demonstrate proof of concept, there's always an enduring challenge, so to speak, as if they might become stranded at the end of their project time. And so by the time ARPA-E funding ends, these technologies, there could still be significant technology risks that need to be overcome before they become market competitive. And so given the magnitude of these challenges, few in the private sector are typically willing to absorb this high risk. So unfortunately at ARPA-E, we've come to realize that this can lead to a high potential and disruptive technologies, really never making that scaling gap to the right-hand side of this. So to avoid that high risk gap, we developed a scale-up program. And it's really here that we're hoping that the teams would give an opportunity to finish their product development, to actually perform market validation at the end of the 3-year scale-up program project, so that they can then attract that venture capital, potentially even growth capital and project financing. And as I mentioned earlier, more recently, with the availability of Office of Clean Energy demonstration funding in their hubs, or even an expanded loan program office opportunity to really attract additional funds to establish that track record and really get into mainstream. So the Scale-Up program is focused on small businesses and companies. That's one differentiator from our focus programs, which can be universities. I mentioned 55% of universities. They're looking at, we look at Scale-Up and pre-pilot projects that have been funded before by ARPA-E, and that would build on these innovations that were achieved in the original ARPA-E award. The applicants must own or control their own subject matter invention or software arising from the ARPA-E award. But equally, they can also be companies that weren't the originator but can license their technology, hence the importance of licensing an ARPA-E technology. There's a number of teams within the two cohorts, operating cohorts of Scale-Up today, 2019 and Scale-Up 2021, that have done exactly that. And then the other important thing which differentiates it from our R&D projects is that the Scale-Up is designed to encourage company and industry participation. So all of the applicants, the leads in Scale-Up, must have a potential customer, end user, supplier as a commercial partner. Even financial partners are encouraged for Scale-Up awardees. So this is our portfolio. As I mentioned, we've got 2 active cohorts right now. for SCALEUP, from SCALEUP 2019 and 2021. You can see it's across a broad range of different sectors, which is very much in line with ARPA-E's R&D activities. We have power electronics from grid, fast charging, aviation, and even 5G energy efficiency from 5G thin gallium nitride, thin gallium nitride switches. We have building technologies, which include new novel materials and lower, very high efficiency, energy efficient cooling systems from SkyCool. Various energy storage groups that I'm going to talk about in a moment, as well as methane emissions detection, which is obviously, as everyone knows and can appreciate, is a very high impact with respect to the emissions in the US. We're also looking at rare earth alternatives. We have an offshore wind project. We have a grid technology for software, and also an industrial efficiency technology, which is being commercialized by Via Separations, and I'll talk about that too. So the first thing I want to mention is Nature and Energy. They're based in Santa Clara. They're awarded $19.9 million in the first scale-up cohort to scale their electrode manufacturing and cell assembly by 30 times up in Holland, Michigan. They've developed a sodium-based technology, sodium ion-based technology for stationary applications that can deliver 2 times the power density and 10 times the cycle life that a lithium ion can do, but also safely recharge it with less than 15 minutes. And I think, so this was a very compelling project for us, because they gave, Nature gave very clear vision of how they were going to move from a small scale to an intermediate scale before going to a gigafactory scale. So it's a very compelling project for us. The next project is Long Path Technologies, based in Boulder, Colorado. They originally came out of the Monitor program, and they developed a real-time continuous and quantitative emissions data system that is essentially static, so it's continuous. It uses a very high efficiency dual frequency cone spectrometer that has very, very high resolution and accuracy. So it can identify up to 90% or more than 90% of the leaks down to a very low leak rate of about 0.2 kilograms per hour from a distance of almost a mile. They were awarded $5 million through SCALEUP. And what was compelling for this technology is they were looking to not just take their technology to the next level in terms of miniaturization, but also reduce costs, identify the areas to reduce costs, really firm up and solidify their potential IRR, and also deploy across the oil and gas industry, and to really ensure that they understood what the customer needed in terms of the service that they would provide. So more than just a technology, it was a service provider as well. So they've actually grown now, and they're serving somewhere in the order of about 16 different customers from just 7 different basins in the mid and upstream assets in the gas industry, natural gas generation industry. With the potential to apply this technology to other sectors, including potentially waste and mining. The next group that I'd like to talk about is Via Separations from SCALEUP 2021. Via came out of originally from MIT. They have developed a new technology to help decarbonize industrial separation processes, which are very energy intensive, with this pressure-driven filtration process. They developed a graphene oxide membrane technology to help improve this efficiency for industrial separations by about 90%. So very selective, very high efficiency separation technology. They came out of the Open 2018 program from ARPA-E. And I think one of what they're looking to do is to look, can they not just scale the size of their membrane facilities, but also improve the efficacy and efficiency of the membrane itself, maintain that and increase that at scale, to look at manufacturing processes to do that, and also to deploy for test and validation purposes their filtration system in a first market application, which in their case is pulp and paper, but which is a very energy intensive aqueous process. But they're also looking to expand into the chemical sector too. So again, with a vision to go beyond scale up and to expand the impact of their technology. So the last team I'd like to talk about today, or highlight, I should say, is QuidNet Energy, and they're based in Houston, Texas. And QuidNet have developed through the DAYS program a very innovative geomechanical long duration energy storage system, where essentially taking, if you like, simplifying this is maybe to take a reservoir-based hydro storage approach, but put that under the ground, so to speak, in a high-pressure storage lens that you can see within the schematic on the slide here, and then utilize that pressured water in the strata of the earth to actually basically run a generator. So use renewable energy to pump the water underground, and then when energy is required, to reverse that and use that pressurized water to run a generator. So their approach is modular in nature. They are looking to build modules between 1 to 10 megawatts. So that they can fit their customers' needs with respect to the utilities' needs with respect to deployment. They're looking for a storage of about 10 plus hours for their system, and they're looking to reduce about half the cost of this with this approach for others leading storage technology that are currently using grid applications. And they're also looking to utilize the existing supply chain, which made them very attractive for scale up. So the pumping technology, drilling technology is a proven technology, safe from oil and gas, but they are actually utilizing it for low carbon applications for long-term energy, long duration energy storage. So a very compelling story, utilizing water, utilizing supply chain that already exists, but is being repurposed beyond oil and gas. And so that's why they are a very interesting team and a really great fit for scale up. So in closing, this is our mantra. This is the mantra we've had. If it works, will it matter? And I hope that I've shown not just how we start and prove that it works, but also how we show that it matters in the field, from our early stage R&D innovation all the way to scale up. And with that, I'd also like to make a plug for our Innovation Summit, which is going to be in May of next year, 2024, in Dallas, Texas. I'd encourage everyone to attend. It's a great opportunity to meet all of our awardees and even our alumni too, as well as meet the stakeholders that are attracted to our event, our Energy Summit event, plus meet everyone from ARPA-E. So with that, I'd like to say thank you. Thank you, SOSV, for giving me the chance, and Stefan, and I will stop sharing. Okay. Okay, so I'll go to the start with some questions, Q&A. I will take a look through. Okay, so the first question I'm seeing here is, what role does ARPA-E play in promoting an infrastructure and regulatory environment that supports zero emissions energy? Well, one of the things we don't do in ARPA-E is policy, so regulations. Our teams have to meet regulations. QuidNet, for instance, not just QuidNet, but all of our teams need to meet the required regulatory requirements, permits, etc. But at ARPA-E, we don't we don't work in that area. We work on developing and promoting the technologies that then will be used and be used to maybe to fit in those regulations. So that's how we work. That's how we work and leave the policy to other groups within the government. Do we support companies outside the US? We don't. When it comes to funding, our primes, that means the leads, the PIs, need to be US based. That doesn't mean that US sort of foreign companies cannot receive, or with headquarters, foreign companies with headquarters outside the US can't receive funding, but they need to have offices and labs and facilities within the US if they are to receive money from ARPA-E for the support. Okay. How does ARPA-E profit from companies and IP it spawns? How do revenues from exits and license providers central source of, I guess it's going to say revenue, right? Funding. No, well, we don't. The way that we profit, as you say in inverted commas for this, is that that our teams that we support, the energy technologies, meet our mission and our mission statement and our goal. So that means if an energy technology that we've supported with taxpayers' money from an R&D group at a university produces a spin-out company which is based in the US, and then produces a product which can be sold here, and also hires engineers, technologists, manufacturing workers, all of the support workers that can go into a company. We see that as a profit for us. That's a win for us at ARPA-E. So that's an area that's how we do it. The IP we look to be, is something, another area, more IP that we see filed within the US Patent Office, the better for us. So we see that as another win. Are you focused on resource security in addition to energy security? Resource security, that's interesting. If you mean in terms of materials, we have the miner program, for instance, where we're looking at alternative methods for mining some of the rare earth elements and key elements that we need in energy transition. So maybe quantifying efficiently turning a resource to, say, a reserve using sort of a materials sort of vernacular there. Then we see that as a security. So we really look at that's probably one area that, from a resource point of view, I don't know if I've answered your question correctly, but whether that is an area where maybe resources is applicable. I'm not sure if I have any more time. It's 5, but let me see. You listed transportation as one of your funding scopes. How do you scope and compare? So we are always looking at other. So this is one thing that we do with respect to overlap with other government agencies. We are always in contact with our other groups, not just within the Department of Energy, but also DOT as well, as this attendees asked me. So make sure that we're complementary to and that we are able to overlap with, but not have overlap with, but be complementary to, and look at these white spaces. So we actually, in the big picture, help are complementary, but we're actually filling a gap to ensure, say, for instance, that we're helping to develop the ultra fast charge, DC fast charger systems, which are bidirectional, for instance, to give an example, that will fit within a DOE's goal to increase charging infrastructure within the US, just to give an example. Okay.
If you see one more question you'd like, go for it. I wouldn't want to. This is the hill I'll die on right now.
Okay, so let me just go a quick one with respect to have companies been funded before by ARPA-E? No, as I say, they don't have to be, but they're for SCALEUP. For any of our companies, they can be. In fact, we encourage new entities. We're continuing to build our ecosystem, but to build our that have not been funded by ARPA-E before to apply. So maybe that one's. And lastly, SCALEUP. SCALEUP include Tech to Market. SCALEUP is run by Tech to Market. So SCALEUP is Tech to Market, as you might imagine, our commercialization team. But working with our PDs, our technical team, our commercialization team runs SCALEUP, as you might imagine. So I think I've got the questions there, Stefan. So thank you very much for all those questions at the time.
That was fantastic. So now the question is, how do they get in touch with you? I know you put up an email address earlier. If you want to drop that into the chat, or I could drop that into the chat, I suppose.
You could drop that into the chat. My email is on our website. That's one way to do that, is contact me directly. I would say go to our website, sign up for our communication sheet, because that tells you of all the events that are coming up with an ARPA-E, not just the new programs, but our workshops and calls for reviewers for programs. So our newsletter is a great way to also keep up to date with ARPA-E, but you can contact me directly as well.
Fantastic. And with that, that's it for breakout sessions. We did it. The royal we. Danny, you were with me for 2 days for this, so I appreciate it.
I felt it, yeah.
And I want to thank all of the people who have trekked from yesterday, from the start of it, from Pale Blue Dot, and have made it here, 30 hours later, and have just been consuming tons of content from amazing hosts such as yourself. And I love that we're able to do this. Thank you, everyone who has joined and sent great questions and connected and let us know where they were from 20 times, because you guys are just gracious guests. Couldn't ask for more. And I did my best to only say ecosystem like 37 times.
I tried to only say it twice. That's good.
Yeah. Well, Danny, thank you, everyone. Get in touch with ARPA-E. They do incredible work. Dr. Danny Cunningham particularly does incredible work. So if you're in touch with him, you're in good company. And thank you so much, everyone. I will see you in 364 days or something. We haven't picked a date yet, but presumably it would be 1 day minus one. And I hope to see you all back here next year. You can all go to the main stage now, and we'll do some fun closing stuff. Danny, thank you, everyone. Thank you. Great to have you all here. And have a great rest of your day.
Thank you very much, everyone. Thank you, Stefan. Bye.